Right, welcome back. We just looked at what are different kinds of raster data that we will be possibly looking at in our future classes. Now, let us look at how exactly this raster data that we have at our hand can be categorized, can be looked into different ways. So I'm going to take out all these three raster files and just get back to only one raster file, that is dem Bhutan for now. And the way I'm dealing with the dem, it's going to be dealt same with any kind of raster files there. So I'm basically going to deal with its symbols, symbologies, and categorization or classification in this one. If we go towards the symbol of the raster, right now it is stretched from 28 to 7,522 meters. If you want to change the color from black to dark gray to any other color, then we just have to click once here and color comes up. On the drop down, we can change to other colors like this. As simple it is. We can choose any color RAM that you want to use. This is the first way. This is the shortest way to change the color RAM. But again, if you look here carefully, it's still stretched. It's not in categories. It's stretched from 28 to 7,222. But if you have to categorize, how do we like to do that? For example, if you have to categorize based on the agroecological zones of the country, how would you like to do that? Then for this one, we basically go to dem, right click it, and go to properties. To go to properties, there are two ways: either right click it and go to properties, or directly double click it. Even if you double click with the left click, it should be getting you to the layer properties. But if you want to go through the other way, right click it and properties, that should be basically displaying the same thing. Let us look at the source of this map. The information that this map is giving us is all in the source right now. There are 11419 columns and 5843 rows. Number of bands is just one right now. Cell size is quite important. What is the cell size of this raster file? We are talking about resolution in terms of raster file, and raster files resolution will be higher if the cell size is smaller. Smaller the cell size, higher the resolution. So the cell size of this one is 29.34 to 56284 meter squared. So 29.3 into 29.3 ml and cell size 29.3 meters by 29.3 meters. That means the elevation that these cells are recording is not that much accurate, neither is not that much vague. What I mean to say is that it's okay, because you're basically expecting that within the square range of 29 meters by 29 meters, we basically should have same value. So like I was saying in one of the classes in my old lecture, I was saying that what I was saying was raster files are basically made up of pixels, and each and every pixel will just represent one value. And when we are looking at one value, for example, this is 29 by 29, 29 by 29, and 29 by 29. These cells are basically going to represent one value. these cells are basically going to represent one value. For example, in the DAM file, elevation file, for example, this is somewhere at the upper hostel, girls hostel, and this is slightly next to the girls hostel. Let's say resident coordinator's home. There should be some elevation difference mostly. Let's not confuse with this example. Let us take another example. Let us take the upper hostel's new cafeteria at this level and football ground at this level. So what it means is that 29 by 29 meters should be representing one elevation. For example, if it is representing only 1400 meter, then this should represent another value. Let's say this is representing around 1300, slightly less, mostly less than, or like 100 meter less. So basically, even if you have some kind of mountainous structure over here or kind of steep structure here, you cannot represent that with one cell. So even if you have very steep kind of structure over in this place, this cell can represent only one value. This cell can represent either 1300, which is here, or it can represent 1200, which is here, or it can represent 1400, which is here. But it cannot represent three of things. So basically, it will represent the highest number of values that it encounters in that cell. So it will be just representative of the values in that cell. So only one value. There should be only 1400. There should be again 1200. So now, if you need very accurate data, then what happens is that if you really need accurate data of, for example, the change in elevation from the new cafeteria to the football ground, because we have got step there, we have got cafeteria here, then we have got steps here, we have got steps here, then we have got football ground over here. Now in this case, if we are to represent by 29 by 29, it's almost impossible to represent everything else at once. But if you have to represent this very clearly, then we need to at least have 1 meter cell size, so that we can basically represent all the difference. If you have to represent only with 29 by 29 cells, then either the representation of this one or either the step one will be taken care by this cell. If you have to represent the step, the gallery, everything by the one cell, we need to represent it by either for the galleries, steps, or either for the ground. So basically, it's nearly impossible to represent detailedly unless we have smaller cell size. But however, at global or macro level, like at the Bhutan's case, I feel that this is fine. 29 by 29 is just fine, it's normal. But if you have to do very critical analysis, then you may need to have more resolution or less size of the pixels. Now let us go to categorization. I was talking about the categorization here. We go to symbology, and after going to symbology, right now it's stretched from 29 to 7522. It's stretched. We can classify, we can categorize. So when we can classify, so let's say which one we want to classify. So this is the whole thing from 28 to 7522. So if you want 5 classes, then we type it as 5 here, then we classify that 5 classes like this directly, then we get 5 classes here. And if we want to make the ranges, for example, right now it's just 28 to 1321, but if you want to make it for example for our fixed range, like in agroecological zones of Bhutan, we can also make that. we can go back to the symbology again, to layer properties. We can classify this one, and we can make two different ranges. For example, we need for example, we need 6 classes for 6 agroecological zones. Let's say we need 6 classes for this one. Let's say we need firstly for with subtropical, with subtropical, let's say we get it from 28 to 1200. Then we get humid subtropical. I'm basically looking at the agroecological zones of the country. Then 2500, let's say. Then we get the dry subtropical from 2500 to let's say 3000. Then we have got temperate, let's say from 3000 to 4000. Then let's say we have subalpine zone, which is from 4000 to 5000. Let's say we have then alpine region, which is from 5000 to the highest, or 7522 in our case. So we have 6 categories here with subtropical from 28 to 1200. Then humid subtropical, dry subtropical from 2500 to 3000, then subalpine to 5000, and alpine to the highest level. So let us try to categorize these values on the TAM. So we need 6 categories. So 6 categories. So what we'll do is we'll write 6 from here, or we can do also from here 6. It's basically the same thing. Then we classify. We keep 6 classes. Here we can choose methods differently. For example, manually, if you want to do manually the classification, like the ones that we are just going to do. Equal interval is basically when we want our 6 classes to be equally divided. For example, 28 to 7522 range divided by 6. So the equal interval that we are going to keep will be divided. That's useful when we have to do some agroecological studies where we have to keep equal interval of our study area. So during that time we can use this one. Then we have a defined interval. So for example, we define our interval, not just 6 equal intervals. Remember, we just give our defined interval. For example, after every 1000 we need to have an interval number. Then we have quantile. It's similar to manual, where we can break our range into different quantities. Then we have natural breaks, which again we would like to break the range very naturally. So these are different kinds of breaks that we use. For now, let us just use quantile or manual. Basically gives same result. So manual, beke, and this is very important. Now let's go slightly to the right side. The classification statistic, we do not have to worry. It's basically the numbers and the figures and sum and mean that is based on our data. Let us look at the break values. The break values are very important in terms of classification. Please note this one, because we are going to look at this again and again in our future GS practicals. Break values are very important because break values are the ones that we are going to look at our intervals there. So first break value is 28 to 1200. 1200 is the first break value there. So mind you that here we cannot see the least. We cannot see 28 here. 28 we cannot see, but we have to assume that 28 is there as the least one. 28 is there as the least one. You have to assume that. and accordingly we have to go with the second range or interval break value. So second one is 1200. Please note this one. So we write 1200. Next one is next break value is 2500. So 1200 is already there, so 2500. So next value is 2500, and next one is 3000 here. Next one is 3000. Next one is 4000. Next one is 5000 here. And the last one is 7522, which is the highest, so we don't have to take care. And whether you're right or wrong, you can also check through this graph. So first range is from 28 to 1200, which is our wet subtropical. Second one, our humid subtropical, from 1200 to 2500, and these are different ranges. So we'll just click OK, and we have our ranges from here. So 20 to 1200 is one class, 1200 to 2500 is another class. So like that, we have got last classes 5000 to 7522. And we can also define levels from that directly from here also, or later towards here. But if you can do from here itself, then it will be good enough, because later it will be confusing for us. So right now we can do it directly. So what I can write is, I can write with subtropical. First one is with subtropical, second one is humid subtropical, third one is dry subtropical, fourth one is temperate, fifth one is alpine, and we have got alpine like here. So we have 6 classes ready with labels ready, and I'll just apply, and that's it with our 6 classes. And we can see the labels coming up here. We can go back slightly and change the color ramp from here. Color ramp can be changed from anywhere, like I said. So let us just use some kind of like spectral color. Okay, this should be fine. Let's see the changes. Yes, so these are different ecological, agroecological zones of Bhutan. Let's just use another color combination. This is quite all right. So this is the agroecological zones of Bhutan. Because we do not have a distinct boundary, it doesn't look nice. So let us just bring a vector file from national data called as Bhutan. I just drag Bhutan over here, and I'll make it hollow so that we can see just the boundary. And that's it. We have a boundary, as well as we have got agroecological zones of the country. That's it with working with the raster file. Next time I'm going to teach you how to finish a map on the same data model. On this same data model, I'm going to finish a map, or I'm going to do the cartography. Thank you.